Hello friends, and I welcome you to this lecture where I'm gonna discuss about the differentiability. So we'll understand the differentiation and the differentiability, the concept behind them first. Then we'll have a look at a small example demonstrating the same, and then the relation between continuity and differentiability. This would be just a one-liner. So let's start by understanding what do you mean by a derivative or a differentiation first. A derivative at a point is nothing but the slope of the tangent of the curve at that point. So if this is your function or this is your curve and you have to find the derivative or differentiation at x is equal to c at this particular point, जिस पॉइंट के ऊपर फंक्शन की वैल्यू f of c है, then the derivative would be आप इसके ऊपर पॉइंट पे एक टेंजेंट खींचेंगे and the slope of this tangent, whatever would be the slope value of this tangent is, that is what you mean by the derivative at this particular point for this curve or this function. Now what is the significance of derivative? It measures the change in a function. So a high value indicates the high rate of change and a low value indicates the low rate of change. आप इस particular point पे अगर derivative निकालेंगे, so you will get a slope like this, a vertical one. एंड इसके ऊपर थोड़ा सा ये लेट गया है, इससे थोड़ा सा आगे बढ़ेंगे तो और लेट जाएगा. सो व्हाट दिस मीन्स, जितना ज़्यादा आपका स्टीप रहेगा स्लोप, जितनी ज़्यादा स्लोप की वैल्यू हायर रहेगी, दैट मीन्स दैट एफ इज चेंजिंग मोर रैपिडली इन दैट एरिया विथ स्मॉलर चेंज इन सी. लेट्स टेक एन एनालॉजी टू अंडरस्टैंड दैट. अ डिस्टेंस टाइम ग्राफ. सो अगर आप वाई एक्सिस के ऊपर डिस्टेंस प्लॉट करते हैं एंड एक्स एक्सिस के ऊपर टाइम प्लॉट करते हैं, देन अ हायर वैल्यू ऑफ स्लोप और हायर वैल्यू ऑफ डेरिवेटिव मीन्स अ हाई वेलोसिटी. उस पर्टिकुलर टाइम पे आपकी वेलोसिटी ज़्यादा है अगर आपका स्लोप ज़्यादा है तो, बिकॉज यू आर कवरिंग मोर डिस्टेंस इन लेस टाइम in that particular area or that particular point. So that is what you mean by the derivative. Now the differentiability. So if you are able to find a unique tangent and its finite slope at a point, then we say that it is differentiable at that point. So let's look at this particular graph again. ऐसा ज़रूरी नहीं है कि आप ये ग्राफ तो बहुत स्मूथ है, बट देयर वुड बी सम ग्राफ्स जिसके अंदर आप ये स्लोप ये टेंजेंट जो है ये एक यूनिक नहीं फाइंड कर पाएंगे किसी एक पॉइंट के ऊपर. अगर इफ इवन यू आर एबल टू फाइंड अ यूनिक टेंजेंट एट दैट पॉइंट, you won't be able to find a finite value for its slope. Consider the word finite value. Okay, so if you are able to find both of them, a unique tangent and a finite slope value for that, then we say that the function is differentiable at that particular point. So the condition for differentiability comes from this particular definition itself, which says the function has to be continuous first of all. Then the function must not have a corner at that point where you are calculating the differentiability, and the function should not take a steep step at that particular point. Let's discuss these points one by one. So first is that function has to be continuous at that point. So consider this particular graph that we discussed earlier also. ये graph discontinuous है. So if I ask you to find the slope at x naught, first of all ये पॉइंट तो आप कंसिडर कर ही नहीं पाएंगे, बिकॉज दिस हैज़ अ होल हेयर एंड दिस इज फिल्ड. सो एक्स नॉट के ऊपर दिस इज द वैल्यू दैट यू हैव, और इस पर्टिकुलर पॉइंट के ऊपर इफ आई आस्क यू टू फाइंड द स्लोप, इट कुड बी दिस, इट कुड बी दिस, और इट कुड बी दिस. यू वोंट बी एबल टू फाइंड अ यूनिक टेंजेंट एट दिस पर्टिकुलर पॉइंट. So if the function is not continuous, then you won't be able to say that the function is differentiable at that point. Second condition is that the function must not have a corner at that point where you are calculating the differentiability. So consider this particular point, it has a corner here. So again the thing comes same. This could be the tangent, this could be the tangent, or this could be the tangent. You can never be sure and to have a unique tangent at a corner point if the graph is taking a corner point. So if something like this is happening, then the function is not differentiable at that point. And you have a third condition which says the function should not take a steep step at that point. So if you're calculating the differentiability at this particular point, then you would be able to find the tangent at this point, which is like this. इसके parallel आपको tangent मिल जाएगा. But the point is that if you try to find the slope of this tangent, it's gonna be infinity, which is not a finite value. Remind you, you have to have a finite slope value. So this is not finite, so we again say that the function at this particular point is not differentiable. Okay, so finding out the differentiability, if you have the equations or the function's definition given, then how would you be able to say that whether it is differentiable at some point or not? So let's consider this graph. मुझे चेक करना है कि मेरा फंक्शन इस पर्टिकुलर पॉइंट पे c पे, जहाँ पे फंक्शन की वैल्यू f of c है, डिफरेंशिएबल है या नहीं है. So what I will do is try to find the slope at this point. Consider this particular arc first. So मेरा इंटेंशन क्या है स्लोप फाइंड करने के लिए कि this point on y axis minus this point on y axis upon this point on x axis minus this point on x axis will give me slope. बट मेरा इंटेंशन क्या है कि ये पॉइंट जो है ये बहुत ही नज़दीक होना चाहिए इस पॉइंट के, सच दैट आई विल गेट अ टेंजेंट हियर. ये कॉर्ड के बदले या आर्क के बदले I should be getting a tangent like this. That would be possible only if I have this particular point very near to this point, which means your h has to tend to 0. And if something like this happens, then you will get a tangent here. And similar is the case for this point. ये point जो है ये c के बाद है, c plus h. Again you would want कि ये जो point है ये point बिल्कुल c के नज़दीक होना चाहिए. Then you will get a tangent here, which would be the same tangent that you are getting in this particular case. So that leads us to this particular statement which says the limit h tending to 0, ये इतना नज़दीक आ जाए कि your h, which is the difference or which is the distance of this particular chord or arc, that should be tending to 0. And your function f of c minus h by c minus this point c minus h should be equal to the right hand side, which is f of c plus h minus f of c by c plus h minus c. This is the slope of this particular right side and this is the slope of left side, and these two will come equal to create a tangent here. So this is the condition for checking the differentiability. There is another representation for finding out the differentiability. So this again is giving us the slope. This is another way of finding the slope at a point. But अगर हमें इस particular point पे या इस particular point पे slope find करना है, so what we want is this c should be very near to x. Then only it will become a tangent, and then I'll find the slope. That will give me the differentiation or derivative value at that point. So my x should tend to c. This x should be very near to c if I'm calculating at point c, and then f of x minus f of c upon x minus c, this would be my derivative value. So this limit in whole should exist in order to say that the function is differentiable. यानी कि left hand limit and right hand limit both should be equal. So let's consider this particular example. It's a piecewise function which is x minus 1 for x less than 2 and 2x minus 3 for x greater than equal to 2. So first step what we would check is checking the limits or the continuity first. अगर ये function continuous नहीं है, then there is no point checking the differentiability because the first condition says the function has to be continuous first. So इसकी आप continuity जब check करेंगे, so left hand limit will be, you will be able to find the left hand limit by putting this function x minus 1, इसके अंदर x के बदले 2 डालेंगे, you will get 2 minus 1, and the right hand limit you will get by this function 2x minus 3 by putting x के बदले यहाँ पे आप 2 डालेंगे, which will give you 1 and 1 in both case. And at that particular point also you will put x is equal to 2 and in this particular function 2x minus 3. We have discussed a lot how to find the continuity, so that should not be a problem. So what you are getting is 1 here for left hand limit, the right hand limit and the points value at that at its point itself. So this is a continuous function. Now let's check the differentiability by using this particular formula. We'll check whether the limits exist or not for this function. So let's check the left hand limit first at 2 minus. So 2 minus के लिए we'll consider this particular function x minus 1. f of x के बदले we'll put x minus 1 and f of 2 के बदले we'll put 2 minus 1 and denominator will be x minus 2. Then we'll calculate the limit. It's giving you 1. Okay, and then let's check the right hand limit, which is 2 plus. We'll consider this particular function for that. F of x would be 2x minus 3 and f of 2 would be 2 into 2 4 minus 3. Denominator will remain as it is, x minus 2, and this is gonna give you 2. So since the left hand limit is not coming equal to the right hand limit, so the limits does not exist for this particular expression by putting f of x equal to this. So what it says is that the function is not differentiable or non-differentiable at x is equal to 2. So that is how you check the differentiability at a point. Then you have the relation between continuity and differentiability. We have already stated that. Let me remind you this thing one more time. So if a function is differentiable, it is continuous as well. That's proved. क्योंकि हम लोग ऑलरेडी देख चुके हैं कि डिफरेंशिएबिलिटी की कंडीशन ही यही होती है दैट द फंक्शन हैज़ टू बी कॉन्टिन्यूस फर्स्ट. ओके, सो इफ इट इज डिफरेंशिएबल देन ऑब्वियसली इट इज कॉन्टिन्यूस, बट इफ द फंक्शन इज कॉन्टिन्यूस इट मे और मे नॉट बी डिफरेंशिएबल. अगर फंक्शन कॉन्टिन्यूस है, जैसे कि हमने इस एग्जांपल में भी देखा था, फंक्शन कॉन्टिन्यूस था बट इट्स नॉट नेसेसरी कि वो डिफरेंशिएबल भी हो. सो यू विल हैव टू चेक दैट. So this is the relationship between continuity and differentiability. Thank you so much.